Yeah, let's get started. I just rephrased the title a little bit so it's shorter. But hey everyone, my name is Alok. Thanks for joining me. We are going to talk about edge computing in general and look at one of the products that I helped build, which is an edge cloud device. And about me a little bit. I'm currently an engineering manager at Oracle Health AI, where I'm working on cloud products which are related to healthcare. So we are using some AI there. But before this, I've helped build multiple cloud products, roving edge infrastructure, which is a cloud edge device, a couple of iterations of those. One other product which I helped build was a cloud migration service, which is something that helps you take your infrastructure and data from a third-party cloud or a private data center and move it to the Oracle Cloud. And in general, I've worked at various companies in networking, databases, large-scale systems, hybrid cloud, so been all over the place. So let's get started. What is the edge? So edge computing has been kind of a term which gets thrown a lot of places. So I've tried to put a place where we describe what edge means. So at the moment, edge means things that are not in the cloud. So the basic idea is that you take the processing closer to the source of the data. But there are several layers to that. So my first introduction to edge computing was about 12 years ago when I was in my grad school at Carnegie Mellon. And I was working with a research team who happened to be under the father of edge computing. And those days, we were working on a concept called cloudlets. So the idea was that a cloudlet is a smaller cloud, a smaller subset of the cloud that can be placed near the user. And your mobile devices, IoT devices could connect to it and operate in a low latency manner and save the data processing. And that concept kind of, got ported into several products beyond research. But edge computing is not something that started a decade ago. It started much, much earlier. And it started at Akamai. And the first edge computing product was a CDN, right? Where you basically cache the data near the user. But that's a little bit about the history of the edge computing. But look at the structure here. We have cloud data centers where the public clouds are, made by these cloud data centers. So your Amazons, AWSs, that's the cloud thing we can see over there, which are connected to typically the network core, which is super high-speed routers, your provider edge, what the networking companies call it. These are very high-speed routers, can process insane amount of data, and typically are connected through these submarine cables, high-speed fibers, things like that. So they can move data really fast. Then we come to the edge. So after the provider edge, there are several things we can include in edge computing. The network edge is where a service provider has enough infrastructure that they can build dedicated high-speed networks to work with your cloud devices. So this is Verizon and AT&T. These companies have built their own small data centers, which are very highly connected to 5G or whatever the latest technology is of the network. So a lot of companies, your Netflix and some other companies, they use this. And this is where we come into a concept of multi-access edge computing. So these devices are supposed to work with either cellular, Wi-Fi, wired. So anything IoT can also be connected to these devices. The idea is that you send the data to these servers, the MECs here, and since there is high network connectivity, you can just move that data to your cloud or wherever you want them. The next level is the edge cloud devices. So these are private data centers, and this is where a range of products come into play, where we have cloud edge devices, which we will talk about later. We have your CDNs, and we have your private data centers. So they are not in the cloud, but they are still kind of heavily connected. So there's better connectivity still in terms of that. But the cloud edge devices are geared to a situation where they can operate without a network connectivity as well. So this is where we start moving to the edge, and we start going into scenarios where we are loosely connected or disconnected from the internet, but still being able to run our applications and use cases. Now, edge devices and edge things. These can be combined together, but edge things typically are sensors and beacons and IoT devices, your home sensors or industrial sensors, your car sensors, things like that. And edge devices, which are typically your hubs, tablet, computers in your cars, in your homes. Your Alexa can be one of those, right? Your Habitat, hub can be one of those. So these are basically aggregators which work with the smaller sensors and take that data and do operations based on some rules or throw alerts or raise alarms around that. So I guess that's kind of the overall structure. On the right side, I've shown where we have connectivity, where the network core and network edge connect through the internet, whereas there is LAN connectivity between private data centers and these smaller devices, and the sensors connect through various protocols. It could be Bluetooth, Zigbee, mesh networks, things like that. So that's kind of the whole ecosystem of edge devices. And there are several use cases these devices are being used in. Automotive industry, we have healthcare use cases where robotic surgeries are being done with some of these edge devices, because the latency is required, which is very low. So you have to place a device near where these surgeries are being done. There's manufacturing, there is logistics, and so on. So why the edge? We talked about latency a little bit. For the applications that are suited here, we need very low latency. For example, you're wearing like a Google Glass, and you're looking at something and you need to react really quickly. So latency matters quite a bit here. You might be making life decisions. You might be a cop who is using some augmented software to make some decisions, which are life and death. There you can't work with the round trip latency, which is hundreds of milliseconds, where the cloud products have that latency. So that's where you need the edge. The bandwidth is not available so much, right? So local connectivity has more bandwidth typically than cloud connectivity. Privacy and security. There are several ways you cannot transfer data. So if you're in Europe, you have GDPR, where you can't move data from one place to another. There are data residency restrictions. There are data governance rules in certain deployments if you're in defense, and so on. So those are something that come into play. Scalability and flexibility. The scalability part here is that having simple devices and repeatable deployments can scale your use cases everywhere. So just bring a deployment and just connect to your infrastructure, and you'll be able to scale your edge deployments much faster. You have a lot of flexibility in terms of where you put these. We saw all those layers, and you have a lot of flexibility based on your use cases where you want to have your devices and deployments. Real-time insights, resilience against outages. So having edge computing use cases protects you from network and cloud outages. Real-time insights can be provided. So The major use case here is that when the data is being created with sensors, the importance of that data is temporal. So that data has meaning only for a very short amount of time. So if you want real-time insights, this is the use case you use these for. IoT and AI. So there is a swath of products being brought in. AWS SageMaker, NVIDIA, and several other companies are building infrastructure where you do the training in the cloud and you do inference on the edge. And not only they are building OEM, I guess, ecosystem, but they're also building their own cloud products for managing these. And we'll visit some of those later in the talk. And adoption, right? The edge computing market is expected to grow quite a bit, 150 plus billion. The whole edge spending is supposed to be around 750 billion by 2030. So the investment is going in because of these use cases. So let's talk about some of these challenges. The first challenge we can talk about is the data transfer. Now, the proportion to data volume and type, right? So these challenges are basically dependent on how much data you have and what kind of data you have. There are two types of data, upstream and downstream. Upstream data is the one that sensors and all these devices are generating at the edge. Now, a lot of this data can be just like useless. So you want to transfer this data back to the cloud. You don't want to transfer useless data and use up the bandwidth and have it charged by the providers. So you want to be able to select which data you're sending. A lot of data has very short time context. So you don't want to transfer that data as well. So you have to pick and choose which kind of data you want to transfer, and you have to tune your data transfer rules to make sure you're only sending meaningful data from the edge to the cloud. Second is the downstream, right? Most of the time, you want to be able to take data from the cloud to the device. So that also depends on the volume, how much data you want to send. The very large volume of data cannot be typically transferred through the network. So if we are talking about several hundred petabytes of data, that cannot be transferred through network in a reasonable amount of time to be made useful. No matter how fast your network is, it's going to take years sometimes to transfer that data. So sometimes the best way to transfer that data is offline. So you typically just FedEx that data by putting them in a drive, right? And we'll talk about one of these products, how they do it. It sounds ridiculous, but that's the most efficient way to transfer that data. And this can be done in both directions. So unstructured data, right? Low volumes can be sent through to the cloud buckets, right? Using simple network. Storage gateways. So a lot of cloud providers have these dedicated storage gateways which have optimized network connectivity to be able to send that data back and forth. So you could use one of those for unstructured data. Higher volumes, again, as we talked about this, can be shipped over disks, so there are several levels. You have disks, you have suitcases, and you have trucks, depending on how much data you want to send to your cloud. Static data, you have CDNs, which have very optimized way to transfer this data if that's the same data. So that's pretty well known and not a real problem area, to be honest. Now, challenges with the structured data. If you're running applications, you have databases. How do you sync these databases? So the requirement for edge computing scenarios and the databases used in these are that they should typically run at every single layer. If you have application to every layer there has to be a database. And you should be able to sync between those layers. So your database needs to have an automatic sync capability. Most of these databases have, but it depends on how you do that, right? There could be aggregation, compression done to reduce the amount of data that's being transferred. Some of the databases that do this are Couchbase, Oracle Exadata, Golden Gate. So these are typically new features that can basically stream your database from one database to another. And as you're using these, you can stream them and use them in different layers. But again, the latency comes into picture where the data being transferred is not instant, so you have to expect that in your applications and build your applications around that. So again, latency goes throughout the chain, as we can see here. So you have to tune your databases, make sure how you're replicating them, how you're sharding them. That's kind of determines the performance of your application, and it totally depends on use case. So there's a lot of it depends in this use case, but it truly is the answer in most of the database scenarios. Infrastructure challenge. How do you build an edge deployment? Do you buy the infrastructure, or you just build your own, right? That's again a decision of how much money you want to spend, what your use case is, and how much locked in you are to a cloud vendor or a particular vendor, basically. So cloud vendors have several solutions for these. One is multi-access edge computing, which is the one that works with the network providers, right? We talked about the MEC, the multi-access edge computing. That's where these cloud providers would give you a data center where there's a very optimized network connectivity. So if you're Netflix or a similar streaming platform, you could basically have your data center there and use your data near the users. So in a big metro center, you could deploy some of these. There's connectivity there, there is a user base there, and you can have a data center where your data can reside and be delivered faster. Another is cloud edge devices. So AWS has a Snow family, they call Snowball Edge, so again, it ranges from disks to the trucks, as I talked about. Oracle has Roving Edge, and so on. And we'll talk about one of these devices later. Storage gateways, these are dedicated endpoints to stream your data to your bucket, basically. Fully managed rack server setup. So AWS Outpost, basically, it's a private data center which is much larger. You have racks of servers, all the network connectivity, all the powers, all the servers, right, and the storage shipped to you by AWS, managed by their cloud software. So it's kind of a hybrid computing scenario where you have a smaller data center near your deployments. So these are the major ranges of cloud provided solutions. There are OEM-built certified solutions. So NVIDIA and IBM, they have solutions where they have certified hardware vendors you could buy your hardware from and use NVIDIA and IBM software to manage your deployments. So that's one way you could get started with your infrastructure. Or you have a self-managed deployment and use some of the open source solutions to connect with your cloud. Deployments and monitoring. So once you have the infrastructure, how do you deploy and how do you monitor this? Again, most of the solutions are vendor locked right now. AWS, Azure, Oracle, Google Cloud, all these providers have edge products, edge solutions. But if you buy one of them, you are locked to their system. You must have a cloud production system which can work with your edge device, right? Which does not fit everybody's scenario. Build your own systems. Again, we talked about that. Very expensive, not feasible for everybody. Open source. So most of us are familiar with Kubernetes. So there's a open source project called KubeEdge. Now this is one of the most popular open source options you have to build your own edge deployments. And what this does is you can use your normal instances in the cloud or EKS or any managed Kubernetes cluster which are there in the cloud to connect with any server. So you have any server, launch a KubeEdge on that, and it would coordinate with your cloud deployments. And this is probably one of the most efficient ways to use open source and open hardware to build your edge deployment. If you haven't checked this out, do check it out. This is a really good project. It's growing very fast. Cloud vendor solutions, again, targeted to use cases. We talked about several scenarios and several cost points and price points. NVIDIA has a Fleet Command, application manager. These are software products which basically help you have a centralized deployment and then manage your satellite edge deployments very efficiently, your deployments, your updates. NVIDIA even has a marketplace where you can pick like an AI model, right, and just deploy it to the edge. So if you want a traffic monitoring solution and you have the hardware near where the cameras are, you just use the fleet manager to pick one from the marketplace, deploy it to the edge, and just start running your traffic monitoring. It will basically, look at the video, identify cars, people, pedestrians, patterns, things like that. And this is just one example. They have several generative AI, medical use cases, chatbots, all of that. And they have a way you can play with that. So do check that out. NVIDIA has probably one of the most complete edge solution infrastructure, because their idea is that you train your models in the cloud and you run them on the edge. And they are providing with several ways to do this, right? So a lot of options there. IBM Application Manager does the same thing, but again, in IBM ecosystem. So we looked at cloud products, some of the software management options, orchestration options, open source ways. There's still a lot of ways to build your own cloud deployments and a lot of options to do that. Monitoring is not super obvious, right? I have a typo there, but the idea is that these devices are distributed, right? And monitoring typically is time sensitive. So again, the same latency comes into the picture. How do you monitor this? Do you have monitoring devices on every single edge deployment? Or do you have a centralized monitoring where you are sending the metrics and logs to a central server where you can define your alerts, dashboard, and so on, and that gives you the insight. So again, this depends on what you want to do with it. There are a lot of options being built for, in general, distributed cloud monitoring, because huge initiatives from all the cloud vendors about multi-cloud, distributed cloud, and connected clouds. So monitoring solutions are being built around those, and there is a lot of potential to adapt some of those solutions to edge use cases, but I haven't seen a lot of specific edge use cases, edge-based monitoring solutions yet. So there's a lot of opportunity to build that, or you might have to customize your own way. So now let's talk about cloud edge devices. What are cloud edge devices? So these are cloud vendor products, of course. So I have had a chance to build one of these devices from scratch. Hardware, vendor selection, building hardware, the operating systems on it, the cloud management side of it. And I have had a chance to build this in a couple of iterations. One of them is called roving edge infrastructure, which is a very powerful server, around 50 plus cores that goes in a suitcase. And another one that's much smaller that goes in like a backpack. So two different sizes. So what are these? These are fully managed and loaded with cloud features. So they run a subset of cloud features in the suitcase. So you could take it in the middle of the ocean and turn it on and start creating VMs, have a storage API, and run all your applications as if you're connected to the cloud. So the best use case for these devices is that you already have a monitoring or any solution that you have in the cloud. What you could do is basically take all your applications, put them in this machine, have this device sent to you, turn it on, and start using them. Some of the use cases that we can, that could be is, maybe in a military, right? There were situations where people wearing HoloLenses have a backpack edge device. So this stream can be processed, and you could react to real-time military scenarios. right? There are several use cases, oil-based deployments where you're in the middle of the ocean, you have several monitoring system checking the health of all your, machines and everything, right? And drilling, right? So they are very time critical, sensitive, latency sensitive. You can use one of these devices to do that. But again, right, you have to, what it runs is your, whatever vendor you're buying it from, that vendor's cloud stack. So it will run, again, it comes in various configurations and shapes, right? It has different core. So you can have storage optimized, you can have compute optimized. If you want to move a lot of data, you have storage optimized options. If you want to move a lot of compute, you have compute optimized options. You can have small disks. You can have, again, there's a truck as well, right, that goes, that drives to you, basically. So AWS provides that. These are very ruggedized, which means they are tested for harsh conditions, minus 40 temperatures. Some of them are even, tested for bomb blast and stuff, right? So very ruggedized and still being able to function in rough environments. They can be loaded with pre-built applications, as we talked about, and data already in the cloud. So you can pick your data and applications, and they will be delivered with your device. They are shipped via common carrier, so they will literally be FedEx to you. When you order a device from a cloud vendor, they would give you a FedEx label, and you can track with that where your device is. When it comes to you, you turn it on and start using it. It provides you with all the typical API access and storage mount options. Again, since you have the hardware, you have options to connect storage to it physically and being able to mount that on this device. But in general, it will run a hypervisor, and we'll look at some of the components that it runs later. And it's managed by the public cloud services. So this is typically what they look like. This is one of the suitcases. Again, different configurations, right? Some of them are just racks, as you can see. Some of them are just hard drive. And some of them are these suitcases. So that's what the inside looks like. As you can see, the case is like typically very strong and can handle rough environments. So again, AWS, OCI, Azure, Google Cloud, all of them have these products. This is the typical architecture of the device. I've taken this screenshot from one of my own articles, but generally, you have the OS. So the OS is a common Linux OS, right? Typically, if you have Oracle, they have their own operating systems, versions and flavors they are running. So you have these operating systems, and on top of that, you are running all these different components. So for compute, you're running a hypervisor, your control plane, your data plane, and you're creating different virtual machines. For storage, you are, again, so internally, your hypervisor would be something that depends on what the cloud has implemented, right? Maybe your cloud has, just Chemo, right? Chemo for hypervisor. They'll wrap layers around it, use that to send commands to create VMs and delete VMs and manage their life cycles and manage the resources on the hardware. Same for storage, right? You might have a Ceph-based engine, storage engine, which is providing with all these APIs, and you have data and control planes, which are basically managing these, right? So a lot of these solutions are open source based, and things are wrapped around them to make it work, but implementation depends on which cloud vendor we are talking about, right? Same goes for the container engine. And apart from these, you have some, the basic services, like you have networking services, and you have identity to help with. Typically, these have control data planes, as we talked about, right? They have physical network devices mapped to virtual ones. So again, being a hardware computer, you have limited amount of network and storage ports, right? And those have to be virtually mapped, and that's managed by your hypervisors and storage engines. API and proxy gateways are there inside to route requests to different. So in a single device, this is basically a, I guess, a microservices architecture kind of thing, where you're talking to different services via APIs, where different network points, and so on, because they have to manage their own credential checks and everything, right? The reason for this is you have to make sure this is compatible with your cloud environment, because this device should be able to work disconnected as well as connected. So if you're connected to the cloud, you should be able to create a VM in this device and then be able to maybe ship that VM to the cloud if needed, right? Maybe you developed something that's really great for one of the, say, oil refineries, right? And maybe you want to ship it to other places. So you move it to the cloud, and then you drop it to other edge devices, right? So there's a lot of movement that can help you distribute your applications much faster and efficiently, based on the connectivity, of course, right? Imported data and images are stored as files. So how do we take these applications and data? The data is typically taken in snapshots, right? The VMs are typically taken as images. So what they will do is they will create a custom image in the cloud from a VM that will contain your drive, like your boot drive and the other drives that were there in that machine. And that will be taken as a file and shipped to this device. And we'll talk about that architecture a little bit later. Yeah, we talked about the new VMs coming in and out. So this is kind of, I guess, how it's built, how we do this in general. This is not very specific, but when you order a device, you typically go to AWS.com, somewhere in the hybrid computing, go and order a device, right? Say, I want one device or maybe a cluster of devices. And depending on that, they'll build one device or a multiple set of devices with networks, right? So they will provide switching hardware if you have a cluster in that case. So you order the device. So looking at this, right, it's a little bit complex than it looks, right? Because the data and operating system images, they are in customer's tenancy, right? And the services that enable this ordering are in Oracle's or AWS's tenancy, right? So they are different things entirely, right? They do not have connectivity with each other. So there is a challenge of how do you get access to customers' data while being a cloud provider, right? That's typically something that's not allowed. You should not have any access to customers' data. So to come around these problems, they basically go and have contracts drawn by legal teams, and they will create a temporary credential for the service to be used in this case. So the customer would allow one user account to the service, which is temporary, and using that, we can access all these things. And so what they'll do is they'll specify that, oh, I want these buckets, these images, et cetera, like, so let's say 10 things of the list, right? And when you do that, these ordering services would go and validate whether the service is able to access those resources or not, based on the account that was provided to the service. And at that point, they'll say, yeah, I can access them, good, order placed. And from that point onward, you are able to, as a user, you are able to just track the status of the order between, depending on whatever states have been defined by the cloud vendor, like, hey, order placed, like processing, provisioning, things like that. Now, another challenge comes here is preparing the device, right? When you get a device, the suitcase, it's just plain bare hardware, right? How do you take some random hardware and connect it to the cloud, right? There are a lot of implications around this. Security is the most biggest one, right? So typically, cloud vendors build a site for this. This would be a room in your data center where there is options to connect external devices. So these devices, there will be an admin side of this. So when the hardware arrives, the admin from the cloud side would basically go and put the MAC addresses, the serial numbers, and everything into these provisioning services. So these devices are identified by the cloud services. Now, once you have these provisioning identified, then these devices can be connected to the cloud. So they are connected to the network, and at that point, this provisioning service would use a very specific lab setup to put the operating system on it, install the operating system, the all hypervisor, and the whole stack, right? Typically, the whole thing we looked at earlier in the diagram, hypervisor and everything, that is bundled as a whole operating system package, right? So we call it, in Oracle world, we call it the Rover OS, which is the operating system for this device. And they would boot up this device. And after that, they would do some tests and validate that everything is working properly, your network ports, your access, and everything, right? So very long process. Now, provisioning service, basically, we work with the ordering service at that point, saying, hey, what are the orders we have got for this device? And we assign the device to an order. And then we use the device. So at that point, the device gets a credential to be able to access those buckets from the user side, right? So look, the way we are looking at this is we are not actually moving the customer data to the cloud side, but we are just taking the data from the customer's tenancy and moving it to the device itself. So at that point, we do a data sync, what we call basically a copy, right? So the whole data is copied, validated, made sure it's error-free, and so on. And at that point, your device is booted, set up, and it's ready. And that's when we create a shipping label and put that shipping label on this and give it to FedEx. And as it gets shipped to you in a week or so, depending on the distance, you're able to receive this device and at the customer side, start using it. So it's a very, very complex process to orchestrate this. There are several roadblocks, issues, legal issues, hardware issues. You need to have certain TPM modules on your devices to make sure things are secure and so on. But that's kind of the overall process. So yeah, after looking at these devices, what are some of the trends that we have seen? Typically, what we have seen is distributed devices and multi-cloud devices are bridging a lot of gaps. So you have the cloud. First, you had things everywhere. Then the deployments were aggregated to the cloud. And then you're starting to disaggregate again. So basically, the idea is that have a seamless multi-cloud, multi-vendor way of deploying your applications where a user has a lot of flexibility to be able to run their applications wherever they want with whoever they want. So those are bridging the gaps which existed of being vendor locked and so on. So this is something that edge computing is also seeing, and we'll see that trend going forward. AI and inference-focused software and hardware ecosystems are emerging. So if you go and look at what NVIDIA is doing, what other companies are doing, there's a huge push around being able, so even Google, the SageMaker, AWS, NVIDIA, IBM, these companies already have products which take your models, dump them in an edge device, and basically run the inference at the edge. So they are not only providing you with the pre-trained models, as we talked about, but letting you use your own custom models to do the inference on the edge. Smaller models, are being developed. We started hearing news recently around, Apple developing models which can run on your phone. So that trend is going to keep going on, and we'll see very specific use cases being developed. The models being developed for very specific use cases for every single type of device, and that trend is going to continue. Again, adoption in healthcare, manufacturing, energy, and small cities are already happening. There's a lot of customers these companies are already sending to. There are white papers, there are use cases already being published. You can go to any of these vendors, and you'll see some of these use cases. Again, a lot of adoption has to come in automotive and robotics, and that's where we'll see things going where autonomous vehicles would heavily use edge computing in a way that the computer sits in the car, and it's basically working with all these sensors in your car to be able to do things more efficiently now that you can do AI inference on the edge. Right? So your AI models will be in the car, and they'll do things for you to make your experience much smoother, your self-driving much smoother, and basically keep iterating on those. Open source options are getting ready, as we talked about Cube Edge. So a lot of open source communities are developing and gearing solutions around these, and we'll see that trend going on. So 5 years down the line, we'll see much easier ways to deploy our edge computing solutions. And that will continue. And other than that, that's all I had to talk. I will take any questions that you have. Thank you. Yep.
Actually, so if there's any questions, just repeat the question.
Yeah, I'll repeat the question.
So you mentioned like in your future plans, I wonder like how do you feel about what Apple is going to do? Like, are you excited about Apple is going to be able to push the edge computing, maybe even change the landscape of edge computing on device inference, maybe even on device training?
Okay, so the question is, what do I think is Apple gonna do around these, right? Are we excited about what Apple gonna contribute to the edge computing landscape? If that summarizes your.
Right. Yeah.
Okay, so that is true, and Apple, the way it does things, it might not be edge computing in the open market sense, but in its own way, right? So yes, the models would be developed for the phones and its other devices, future devices, right? We are looking at Vision Pro, which is one of the more suited use cases for edge-based models, I would say. So your virtual headsets and your phones might work together in an edge computing scenario. So yes, Apple is gonna do a lot of work in edge computing, but they are going to be very targeted towards the product they are going to develop. They are going to show a lot of things that can be done, and as needed, industry would adapt to them, if that answers.
Well, because if you look at the current approach using this FlatX ship, the luggage size device, and you possibly running a Kubernetes, right, some sort of hypervisor on top of that. But I feel like with like foundation model and also collaborative like machine learning, and with the I think the iPhone is it's probably the next iPhone with a newer engine will be powerful enough to for sure for inferencing. But I think it's probably even capable of some sort of machine learning. Right? That will the whole point of like Apple is like they have to do it because the privacy thing is they're selling. But
Yes.
I'm saying like if they be able to push this forward and do all these sort of so they have to do that. They have to make that work because that's their selling point.
Yes.
I think that will actually push Google to do it because Google's so focusing on the cloud training. They have to call back Google to get the stuff right. I don't think they're really focusing on the parts.
Yeah.
So that's my question. Like I feel like they will be able to push that forward and change the entire landscape of that. Instead of running, like a luggage size device. It will be just the device on the top.
Yeah, and I agree with most of that, right? Developing foundation models on the edge is not something that's going to happen very soon, right? Uh, Doing the training on the edge is not going to happen very soon. RAG is not also going to happen very soon, but inference is something that exists right now, and it's going to keep happening. But again, as you said, if Apple ends up developing much more powerful chips that can do these things on the smaller devices, yes, of course, they're going to be able to do that. Right now, the biggest limitation all these solutions have is the hardware. NVIDIA is making them, and maybe some others are making them, but they just shorted up those. So if Apple is able to make hardware that can do this on smaller phones and smaller devices, yeah, of course. That's something that I do see happening. Yeah, thank you. Any other questions? Okay, thank you so much.